Hi folks, this is the 18th problem of the DSA series, so let's get started. It says design a stack class that supports the push, pop, top and get min operations. First let's have this class, stack class that supports all of these operations. So minStack initializes the stack object, so let's rename it to the minStack class. Now we got to have all of these functions in this class: push, pop, top, get min. So first let's go step by step. Let's write these functions first and then we'll again read the question to know what it exactly wants. Push, pop, top, get min. Okay, top, and here we have get min. Okay, these are the functions that it wants us to write. Each function should run in O of 1 time. Okay, so each function should run in O of 1 time complexity. Okay, so push pushes the element onto the stack, pop removes the element from top of the stack, top gets top element of the stack, get min retrieves the minimum element in this stack. Okay, so you can think of it like this. If we push 1 in the stack, it will be pushed on the top of the stack, then 2 will be pushed on top of 1, 0 will be pushed on top of that, and then if we run get min, then it should return the minimum of all of these elements, which is 0, right? 0 to 1, which is the minimum, 0. Now if we pop from the stack, which element is at the top? 0. 0 will be popped off the stack. Now if we want to see the top element from the stack, now since the 0 is being popped off here, the top element becomes 2. So it returns 2. Now again, if we see get minimum, then out of 2 and 1, which is the minimum? 1 is the minimum. So yeah, so it should return 1. Now the key is that all of these operations should happen in O of 1 time complexity. Now if you see, if we initialize an a simple array named stack in the constructor, it can do push in O of 1, because if we push something at the end of the array, it is an O of 1 operation. When you pop something from the end of the array, or we can say from the top of the stack, it is again O of 1. If we want to see an element at the end of the array, or we can say at the top of the stack, it is again O of 1. So all these three will be O of 1 if performed on an array, right? However, if we want to see the minimum element in the array, we got to iterate over every element in the array, which is an O of n operation. However, here it wants it to get done in O of 1 time complexity. Now this is a little challenging, right? So let's get started first, then we'll solve this challenge as well. Now let's do simple push this dot stack dot push. How we do push in an array? That's it, dot push whatever we get here. Let's push the number here, right? Now we wanna pop, then simply do this dot stack dot pop. That's it. It will pop the last element from the array, top. We wanna see the last element in the array, or we can say the top element in the stack. So we'll return, because we wanna see this dot stack, then we can say this dot stack dot length minus 1. This will give the last element of the array. Now all of these three are performed in O of 1 time complexity. Now let's focus on solving this in O of 1. For that, let's initialize another array, this dot let's call it minStack. Okay, now so what I am thinking is, let's say this stack array is 1 2 4 3, right? So the minStack will be, so minStack will simply, when 1 will be pushed here, the minStack will say, so minStack will track this stack array and will keep record of the minimum element at a particular index. For example, when 1 will be pushed here, it will say okay, so 1 is the lowest one. When 2 will be pushed here, it will again keep 1 here, because out of these two, 1 is the lowest one. So that is till the first index 0 1, till the first index 1 is the lowest one. Now till the second index, which is the lowest one, again 1 is the lowest one. Now till here, which is the lowest one, again 1 is the lowest one. Let's say we have 0 here, then we get 0 here. Now which is the lowest one? 0 is the lowest one. So the number of elements present in the stack array and the min stack array are equal, right? The only difference is the at every index min stack will record the minimum element till that point of time, right? For example, if let's say here we had like 3 and here we had like 1, and this could be the array, then when 3 is pushed, here at this point we have 3, right? Here the minimum element is 2 and here the minimum element is 1. In this case it will be the similar. Okay, so this is what min stack will do, and here in the get minimum will simply give back the minimum element, that is the element present at the end of the min stack. As simple as that. Now let's do it. So we gotta keep record of the minimum element at each index, right? For that, let's do this. Let's say const min current min, let's call it current min is equals to whatever element is present at the end of the min stack, that is this dot min stack dot length minus 1. Okay, whatever element is present at the end of the min stack is the current minimum. Okay, however, initially you can see there is nothing here, so it will give us undefined. So we'll do this dot min stack. In min stack we got to push the minimum element at each point, right? Since we added an element in this stack, we got to add an element in min stack as well. The min stack, again I am reiterating again and again, the min stack will contain the minimum element present till that particular index, right? So here what we'll push, we'll check if current min equals to undefined, which could be the case here initially when there is nothing here, then in that case simply push this num, which will be the very first element in this stack. If this isn't the case, if this is not the case, there is something here, then simply do math.min and push whatever is the minimum out of num and the current min that we have, right? Understood? So it will push the minimum element at that particular index. In case of pop, since we are popping element from the index, and we know the stack and min stack should be of equal length, because min stack is simply doing nothing but tracking the stack, right? So we got a pop from here as well. This dot min stack dot popping the last element from the min stack. Okay, and here from in top we got to return the last element present in the stack, or the top element from the stack. So yeah, this seems correct. Now this get min is simple, we don't have to map over the stack array, we can simply return this dot min stack, the last element present in the min stack. So we'll say min stack dot length minus 1. Yep, so now along with these three, this as well is of O of 1 time complexity, right? So yep, I think it's done. Yeah, if you learned something from this video, I would really appreciate if you could click on that subscribe button. Thanks for watching, guys.